It's Annalie again. This time, speaking from Caputh, which is near Berlin. I'm standing in front of Einstein's house. Well, his summer house, even though it doesn't really feel like summer right now. I'll be speaking with Jürgen Renn, who is an historian of Einstein's work. Hi, Jürgen.
Hi, Annalie.
Can I speak to you about black holes today?
Of course you can, although it's freezing outside.
Is it really true that Einstein didn't even believe that black holes existed?
It is true. Einstein's work showed that black holes must exist. We know that they exist today, but Einstein couldn't believe that such strange objects would actually have reality, and he was not alone in this disbelief. It's a strange fact. They are common to us now, but at Einstein's time they were just monsters.
Is it true that the basic idea of black holes existed even before Einstein's time, in the late 1700s?
Yes, Annalie, it may sound surprising, but that's actually true. In the late 1700s, people believed in a theory of light. They followed Newton in that light consists of a stream of particles. And if the gravitational pull of a large star is strong enough, that stream of particles is simply held back, so light cannot escape the star anymore. And that's why they talked about a dark star. And that's really like a black hole. It's a star that has gravitation but is otherwise invisible. But then the idea got forgotten, because people changed the idea of light. They then believed in a wave theory of light, and it was much harder to accept such a notion of a dark star with a wave theory. So the particle theory of light got forgotten, and with it also the idea of a dark star, a black hole.
I talked to Christian Ott about supernova explosions and gravitational collapses, and he said that even in the 1930s, gravitational collapses were existing and were known about, but the idea of black holes was still considered crazy. Why?
True, they talked about gravitational collapses at the time, but they couldn't imagine that it would go so far as to produce an almost infinite density of matter in a finite time. Einstein in 1939 even tried to prove that black holes couldn't exist, that a collapse could never yield a singularity as it was mathematically possible to imagine, but physically it just seemed to be nonsensical.
But when did they start believing in black holes then?
Well, it started to change in the 60s. The mathematics was gradually worked out. People pursued this strange mathematics of black holes into its consequences, so a consistent model of a black hole could be formulated. And then also observational astronomy made big advances. X-ray astronomy came up, quasars were observed, pulsars were observed, and gradually people could trace the signatures of black holes. For instance, the matter that is drawn into a black hole emits X-ray radiation, and that radiation could actually be traced.
I spoke to Günther Hasinger and Reinhard Genzer about the acceptance of black holes, and they said there's even a giant one in the middle of the Milky Way now. But just because they're accepted, does it make them really real? Are they really there?
First of all, they have now fantastic observational proof for it because they can trace the motions of stars right around this object in the middle of our galaxy, and that's almost a visual proof for it. But what makes us as physicists and historians and astronomers believe in black holes is more that they fit now into the entire zoo of cosmic objects. They are no longer the exceptions, but they are almost the rule. And we have so many facts pointing at them and so many theoretical consequences that are tightly interwoven with our theory of the universe that it would be hardly imagined a universe without black holes.
But it's still just a theory, right? It still doesn't make it true.
Well, what can I say? A theory is the best that we have in science. A theory is not just a single fact, but it's a network of facts that mutually support each other. And in that sense, it's a real achievement. And only when observational and theoretical work goes further, the theory may change, but the knowledge that is within the theory, that is sort of stored in the theory, will remain with us.
Here we are in Einstein's bedroom and study, where he probably tried to disprove the black holes. So astronomers keep telling me that black holes are really there, but you keep saying it's a theory. So which one is it? Well,
it's a fact and a theory. Actually, a theory is even better than a fact because theories put order to facts. Let me explain to you by comparison. If you have a criminal story and there is a murderer and you have the confession, that would correspond to a fact. But there are false confessions, so how do you know that's actually true? And there you need circumstantial evidence, you need other facts, you need a fingerprint or you need a DNA trace. And that's the theory. So the theory is in a way an order, a structure of facts, and it's a collection of facts that support each other mutually. So it's better than a single fact. And that's what we have in the case of black holes. We have a lot of facts that coherently show us that in our universe there are a lot of black holes, actually.
So is that the end? Is that they're there and that's the end of it?
Well, I don't believe that physics has come to an end. There's still a lot of open question. For one thing, we are still waiting for an experimental proof of the gravitational radiation that should be emitted when black holes form. We are just there at the threshold of observability, and I'm convinced that eventually we will get that proof. But even then, I would say the story isn't over yet, because there are many open physical questions. The black holes comprise a singularity. We cannot look inside, but there's interesting physics that must be going on. And in order to understand that physics, it's even possible that we have to extend our notions, that we have to bring in quantum theory, or it's sure that we have to bring in quantum theory. And nobody knows yet for sure how to bring together relativity theory, which shows us that black holes exist, and quantum physics that shows us what is actually happening inside with the matter that has been swallowed by a black hole.
So if this happens and it's proven that black holes are there, how does that help the physicists? How does that help the world?
Well, it helps the world that we understand our universe in a better way. And sometimes it happens also that when we make observations in the extremely far universe, we understand better also the physics that is near us. And because it's a theory, because things hang together, it's not isolated facts out there, but the facts there and the facts here are hanging together. And our world picture should be one. The notions of space and time that Einstein introduced in order to describe strange effects in the cosmos are notions of space and time that change also the way that we think as human beings about space and time.
What do you think Einstein would think if he knew what his general relativity theory was doing right now?
I'm sure on the one hand he would be quite surprised. He would be unhappy because some of his preconceived notion, he believed initially in a stable, harmonious universe that wouldn't change, and now we are living, as we know, in a dynamic universe with monsters such as black holes in it. So I'm not sure whether he would like that altogether, but he should surely be satisfied that his theory has had so many consequences that even he himself couldn't foresee.
But you started out as an astronomer, right? How did you get into the historic side of science?
Yeah, I wanted to understand how such strange things, such scientific revolutions as Einstein's relativity theory is one of them, could actually happen. How human knowledge develops in historical periods. How people are able to discover new things. What are the preconditions for that? What are the consequences of that? I prefer to work on these kinds of problems rather than to solve, a specific scientific problem. It was interesting to see sort of ideas on the move.
So how does it feel for you being inside Einstein's house, where he created so many of his revolutionary theories?
It is certainly a special feeling. Also, if you consider how little is there in this room, how little you could put on his desk, and without having big instruments and a staff of collaborators, Einstein basically rethought the way that we conceive our universe. It is really impressive indeed. But it's also a feeling of melancholy that comes when you are in this house, because we shouldn't forget that Einstein was forced to emigrate by the Nazis from Germany. Yeah. He left this nice house behind. He had to leave it behind. He had to leave his sailboat behind. He was forced to emigrate, but he was also lucky to escape in contrast to so many others who lost their lives. And when we think about the historical development of such great theories, we shouldn't forget the fate of those who created it.